There we
We're
go.
live.
I think we're live. All right. Yeah, Peter's not here today. He's the one that usually runs these StreamYard streams, but I'm here, and I have a lot of power here. I'm trying to run this thing. Don't know what I'm doing really, but
Peter left town and left his keys on the counter to his car.
And here we go.
His roommates are like, "Hey,
yeah.
let's go for a ride."
All right, so yeah, thank you all for joining. Today we're going to be talking about kagent and adding guardrails to the communication paths in kagent when we communicate out to external LLMs and or any LLM really. And yeah, that's hopefully interesting. Does that sound interesting to you all?
That sounds super interesting.
I think, like, to tie it back, like because how many weeks ago was this? Time flies here, but like the one where the live stream where we talked about like the data path or data plane for AI, right?
Yep.
And like MCP and A2A are like everybody's talking about that, but like don't sleep on the fact that at the heart of every agent there's an LLM and the same security governance, like routing, observability concerns apply to that call from the agent to the LLM as well, right?
That's right.
Yeah.
That's right. And there's a number of ways to do this. The way we're going to look at is so in that previous live stream. So go back and check it out. We talked about how do we secure the communication paths from the agents to MCP and potentially A to A. And those are very, very specific protocols and things that we can do there. But this is, we're sending traffic to the LLM. It's HTTP. Can we add things like prompt guards or guardrails to that traffic? And that's what we're gonna take a look at today.
Before we get started, should we talk about the good news?
Definitely we should talk about that.
I don't seem to have access to post things in the chat, but for those who don't already know,
I don't either.
kagent was accepted as a CNCF sandbox project. So
can you see that?
We can see you.
Yeah.
Oh.
And Peter is so much better at this than you are, Christian.
All right, let's try it like that.
I mean, something's happening now.
Yeah, it's definitely thinking about something.
We're
looking at just like a solo IO background, but not.
Yeah, for a moment.
Oh, building suspense. I like it.
Yeah. Okay, we got that, and then and boom. Then boom.
All right, so
ha!
There we go.
Look at that, maximum impact.
Yeah, and here I'll even maximize the text. Oops, that didn't work. Boom. All right, this is what we wanted to talk a little bit about, right? So kagent is accepted into the CNCF. Woohoo!
Amazing.
Yeah.
I'm happy. I'm pretty happy about it.
This is incredible, right? I mean, because when we all started this project, we just saw this as like a gap, something we were building and the community benefit from. And then after KubeCon realized, I mean, certainly with like the adoption and then just how much engagement we've had in the community, and then post KubeCon saw that how many other people wanted to contribute this. I mean, not just consume it, but contribute to it, right? And so this is awesome. And I think we're going to start seeing a lot more. So now that it's officially a CNCF project, a lot more first-class integration with other CNCF projects and some of the CNCF infrastructure.
Yeah, agreed. Yeah, I mean, even up till now, the community has been amazing. I know, Eitan, you probably spend a lot of your time reviewing PRs that other folks are sending in.
Yep, indeed. Yeah, and I just want to thank all of the TOC members who voted. Thanks for taking the time and peeking at our project. I mean, obviously, I'm a little biased. I think it's awesome. But it's also cool to see that other people think it is too. So
yeah. So if you're looking to build agents quickly on Kubernetes, this is it, kagent. All right, so let's go. We're going to go to the website. We're going to take that part down though. Why does it say solo right there? Oh, that's the UI. Okay, so here's the kagent website. So this is what we're gonna talk about today. With kagent, when we build an agent, you give it a system prompt, you give it access to a set of tools, and then you it runs in a Kubernetes cluster, and it can do a lot of AI reliability engineering type tasks like debugging, like promoting code between environments, setting up security posture, evaluating security posture, and so on. But one thing you keep pointing out, it's the system prompt, it's the tools, but it's also an LLM. You need a model. You need an AI model there. And in the docs here, if you come over to the docs, hopefully y'all can see that. I'll make it a little bit bigger. Yeah. In the doc here, you see under the getting started and quick start, building your first agent, building your first MCP tools, writing system prompts, but then also configuring the backend AI models that you can use. We started the project building around OpenAI GPT 4.0, but we've had a lot of asks from the community. Hey, can you support other models? And of course, that was always the idea, and that's there now. So if you want to configure Claude, or you want to configure your own models running on Ollama, this is all you can do that. So the way that you do that is through an object called the model config. And in the model config, you specify where the keys are to be able to call that model. If there's a custom endpoint, then you can do that as well. And that is exactly what we're going to do in this scenario, because in the demo that I'm setting up, I want to use an agent that talks to a AI gateway, a proxy, that then talks to the upstream backend model. And in that proxy, we can apply policies about that traffic. We can monitor the traffic, do telemetry and metrics collection, things like tracing. And actually here in the documentation, here's exactly what we're going to do. We're configuring custom models. We're going to continue to use OpenAI, but we're going to route the traffic through a proxy and take a look at what we can do with that proxy. Any questions about that? Anything that you want to add?
No, that makes total sense to me. I mean, I think, from talking to people in the community and just having a lot of conversations over the last year, this is like top of mind for so many infrastructure and security people. And so I think I'm really excited to see this integration with kgateway. So
yeah, exactly. So kgateway is the project that we're going to use. Also a CNCF project. Kgateway is an API gateway. It's been around for a long time, probably about 7 years, under different name though. It's called Glue as an open source project, or Glue Gateway. But was donated back in November, I think, is when we made the official announcement on stage at KubeCon.
That's right.
And I think it went in earlier this year officially. But so kgateway is an API gateway, but it also implements, if we come over here to the doc, here, can you also see? You probably can't see that very well. It also implements AI capabilities. So, I'm having trouble apparently with the website. Nope, not security. AI gateway. All right. So in kgateway, we've built AI model communication awareness into the gateway. So with the traffic flowing from an application, in this case, kagent, to an LLM, with the gateway in line or in the communication path, what we can do is things like specify authentication and authorization, so that it matches more closely what you're doing with your APIs internally, right? Internally, you might be passing around your own internal API keys or JOT tokens or mutual auth or something. Whereas the providers, they have their own API keys. You don't really want to send those API keys around to everybody in your organization. You want to build on your existing foundation. So integrating with your own authentication authorization and putting policies around that and which models can be called and so on. Implementing things like model failover. We're going to take a look today at prompt guards or guardrails, where we can identify sensitive information in the prompts that might be trying to go to the LLMs or coming from the LLMs. And we can block it or we can mask it. We can call out to things like content moderation services. We can call webhooks to integrate our own guardrails and so on. So kgateway is a powerful API gateway that runs on Kubernetes, but it also it implements AI capabilities or AI awareness and can be used as an AI gateway. The last thing I'll point out here is that kgateway also, wow, is my internet this bad? Also implements the gateway API's inference extensions. So here, if we click on that, the inference extensions is a way to give the proxy more smarts about what's happening on the backend LLMs if you're hosting your own LLMs. So if you're hosting on your own GPU infrastructure, we can make the proxy smarter about what's happening with the various KV caches on the GPUs, where are fine-tuned LoRa adapters deployed, things like the waiting queues, the depth of those waiting queues, so that the proxy can be smarter about where to send that traffic. Actually, that last thing, why not? The last thing I'll point out is this new project LLMD, which was just announced, which takes what I just explained, that inference routing, to another level and brings in distributed inferencing. But kgateway is the primary routing layer for this new project that was just announced.
Is inference extensions getting renamed to inference gateway, by the way?
An inference extension, I think there's some discussion, but they do refer to inference gateway as something that implements the inference extension APIs right now.
Right. Okay. Yeah. A little bit slightly better name if you ask me, but
yeah. Oh yeah, I agree. Okay, so if we're gonna do this in kagent, let's first switch, if I can, to my terminal here. And let's share it. Boom. Look at me. I got this. All right, so we got this Kubernetes cluster here. We have kagent running in the cluster. Here, let's see if I can make this a little bit bigger. Hopefully that's all right. And so what we're going to do here is we're going to. No, that's not what I was trying to do at all. All right. So what we want to do is we want to set up kgateway. We're going to set up kgateway, and then we're going to tell kagent, hey, when you talk to a model, talk through the proxy. So we're going to do set up kgateway. We'll take a look at what that does. It's pretty easy. We're just going to use Helm. It just checks to see if we have the gateway API installed, because we'll need that for kgateway. And what we're going to do here is just do a Helm install of kgateway. All right. We see kgateway system has now been created. If we look in here, the control plane part of the gateway is up and running. We haven't created any gateways yet. So if we take a look at kgateway, a gateway resource, what we're going to do is we're going to open up ports on 8080, and this will expose it as a load balancer, so it's externally accessible. Let's go ahead and apply that. Okay, gateway. All right, now that we created this gateway using the gateway API resource, we should see a new actual data plane spin up here. So here's the AI gateway that's been spun up once we created that gateway resource. So we'll give that a second to come up. The next thing we'll take a look at is gateway backend. And so what this does is configures a backend or upstream in our gateway to be able to call to OpenAI. And we'll give it the tokens and secrets and so on. And we'll just tell it what model, when it comes through this path, we can control which models it'll go to. In this case, it'll go to GPT 4.1 mini, but we can specify whatever we want. We can give it failover rules. We can do all kinds of things with the backend once we call it. We can even split traffic across multiple providers. Right, so we'll add that. Okay, gateway backend. And then the last thing we'll take a look at is the HTTP route. So this route says, hey, if I route traffic through the gateway at /OpenAI, then send it to that backend that I just created. And then the backend knows how to add the OpenAI tokens, how to specify the model, and it'll overwrite the model. If somebody writes something else into the OpenAI prompt, it'll rewrite the model's name into what we specified. So we're already starting to get a level of control here. So apply that, gateway HTTP route. Now, if we come to the terminal here and look at our Kubernetes cluster, we see the gateway is up and running, which is great. And then gateway, if I come here, if I call, cross fingers, actually, hold on. That will probably not work. One step I missed, which is creating the secret. Hopefully that all works. Let's find out. And I'm going to try to call the gateway directly. Actually, let's go here. If we take a look at the services running, we see that we have an external IP because we specify this as a load balancer service. So I should be able to call this IP at /OpenAI. And let's try to do that. Cross fingers. All right. Boom. All right. So I was able to send a prompt to the gateway. The gateway was able to use its credentials and routing and know how to call OpenAI. All right. So now let's add this to our kagent. So what was that? So this external IP is going to become useful for us. So I'm going to copy that. And then, all right, now I got to switch back. To our browser, which is where? Here. Boom. All right. Does that work? Can y'all see that?
Yes.
All right, cool. So now we're at the kagent web console. This can all be done in custom resources as well. CRDs, you guys make for better demos. So what we're going to do here is we're going to create a new model, and this is going to be an OpenAI model. We'll just call it mini. Help us filter down. We'll come here. We'll find GPT 4.1 mini. And in this particular case, we're going to say I don't need to provide an API key to OpenAI. The proxy is going to handle that. And then we'll come here and we'll put our port 8080. So this is the route that we configured on the gateway. So now when kagent talks to OpenAI, it'll talk through this gateway. So let's go ahead and create this new model. So this is going to be called OpenAI GPT 4.1 mini. So now if we look at, now we'll take a look at one of our agents. We'll look at the Kate's agent. Right down here. Oops, let's actually refresh it. Down here, I'm going to switch the model that the Kate's agent uses from the default out of the box model to the model that we just defined. And we'll say update. All right. So now when I click into the Kate's agent, actually, I wonder if I should just share my whole screen so that you can see everything that's really happening.
See the traffic going to the proxy.
Yeah. I'm going to share my whole screen. I have kind of a wide screen. Hopefully that doesn't, hopefully you can still see up here. Let's put this up there. Hopefully you can see that. All right. On the left-hand side, what we're going to do is we're going to watch the logs on the proxy. I'm going to clear it out. On the right-hand side, we'll take a look at this this chat, and I'm going to say, hey, tell me about Kubernetes in 20 words. Now, if I send this prompt, we should see traffic flowing through the gateway. And you can see that we've had some responses here in the stream. And so now we have traffic going from kagent to the proxy to the upstream LLM. Now, what's interesting about this is that we can add guardrails, we can add policies. So if I click on a gateway, come over to prompt guards, we can add things like watching for credit cards, masking sensitive information if it's coming back from the LLM or going to the LLM. And so that's what we're going to try now. So I'm going to say cat the prompt guard. The first prompt guard we're going to look at is if the agent is asking about credit card information. However, it got tricked into doing that. Maybe a user if it's a chat initiated agent session, or if it's been tricked into calling tools that inject this type of prompt, then we can catch that at the proxy. So if I do if we apply this and come back to the traffic here, come back here, and I say, hey, can you get me some credit cards? And I send it. We'll see on the left-hand side, the proxy has recognized that, hey, this is some sensitive information. We gotta not allow this through. And here you can see, hey, don't ask me about, doesn't say specifically, but it says, hey, I'm not going to give you credit cards here. Ask me about Kubernetes related stuff. Here's another example where maybe the LLM did get tricked into giving us back some sensitive information. And in this case, what we want to do is mask that sensitive information. So this is on the way back. The LLM's giving us some information. We shouldn't expose this to the agent or to the user. And so let's mask that out. This can also be used on the request path as well. I'm just showing you both. So if we do apply prompt guard mask, and then we say.
So Christian, there's a question in the chat. I don't know how Peter does that thing where he pops it up.
I bet you I don't know either, but
someone
said,
can an external service be called to apply guardrails?
Yes. Actually, I'll let you answer that one.
What's he supposed to say now?
You can go into more detail. I mean, you wrote it.
No, I can. So the answer is yes. It's interesting because when we were building this, we put some pretty basic guardrails into the product, into kgateway, but really what we said is that this functionality is so so context dependent and so use case dependent. So the real feature that we added was the webhook. That was the first thing we added. So yes, you can absolutely call an external service, an internal service, anything you want. We have an API that we define that you can implement.
Yeah, good question.
So Christian, I wanted to make a comment about guardrails. Whoa, PTO really messed me up. I want to make a comment about guardrails and how that, like when we bring the whole picture together with MCP and A2A, but I didn't know if you were building to that. So I can like save that for later, for the end, or if now's a good time, or.
Why don't I do this last part?
All right, cool.
The demo, and then we can talk about it. Yeah. Right. So we added this guardrail to mask sensitive information. I'm going to ask it's kind of hard to get the LLM to give you sensitive information. So this does seem to work. So I'm going to ask it about this number. The guardrail should identify this as a credit card number, a MasterCard, probably 5105. Right. Okay. So now we sent this off to the LLM. It responded back with the number, but we identified this in the gateway as a sensitive proxy or sensitive information that we were able to apply guardrails to in the proxy.
And I just want to point out something that is I think worth paying attention to, is that was a streaming response that was masked.
Right.
Which
that is right.
I don't know, most is kind of I don't know, it's not, it seems like not a big deal, but from what we've seen, most solutions actually require you to not do streaming in order to achieve guardrails. So that's not something that you have to give up when using kgateway's guardrails. So
that's a great point. Yeah. Okay. So Keith, you wanted to make the point about.
Yeah, I was just like, I think because you demonstrated, and I just want to like double click on it to make sure it's clear that and tying maybe past sessions together. So like in the context of an agent executing, right? It's got some system context that the agent developer is giving it. It's got a user prompt that's actually coming from the person interacting with the agent, whatever form that takes, right? That gets generated, or it's actually like really a natural language prompt that comes into the agent. Interestingly, and I think like more directly about that calling immediately to an LLM. But some of the things that you've talked about, Christian, about once you calling out to tools, right, and all the exploit vectors there of rug pulls, impersonations, masquerading, all that kind of stuff, right? That this also, we're going to protect against that in the MCP tool call. But I think as well, we're having an additional safeguard here in that call to the LLM, because you have a situation where a tool is maybe injecting context that you don't catch in that traffic plane. Then you have an additional defense in depth layer here as you're calling out to the LLM and getting a response there, right?
That's absolutely right. So like you used the words right, defense in depth. So there's multiple ways we can stop MCP tool poisoning. Things like setting up an approved registry and having audits and workflows to get tools approved and try to detect changes. Once you're calling the tools, can you have guardrails on the tool calls themselves to catch that stuff? But what you were talking about is when you go out to the LLM, that's kind of the last path, and we can apply those guardrails and content moderation type stuff there too. Yeah.
And I actually feel another live stream brewing here in the making is like this one dedicated to like what a defense in depth strategy looks like for agents, basically, right? I think that would be very cool.
Yeah, definitely.
And is it fair to say, now I'm going a little bit, you and Eitan would know better than me, but I think we talk a lot about, especially in the classic AI gateway LLM consumption scenario, where you're like, all right, I'm getting a prompt directly and I'm protect against it. Agents, it's actually, there's two layers there, right? There's what the user feeds you or feeds the agent, right? And then there's actually sort of the system prompt governing the agents, how it's going to accomplish that objective, basically, right? And yes. Do you feel that, like, are we really going back to defense in depth, or like who the personas are? These guardrails not only protect you from like end users interacting with agents, but maybe someone, maliciously or, accidentally makes a mistake in crafting their system prompt and it could catch it there too, right?
Exactly. Yeah. No, that's a good point. I know you've been involved with some of the customers where they need a like a kill switch type scenario where you trust the developers to build in some guardrails. You trust the hosted provider to provide some sort of guardrailing system. But then if something does slip up for whatever reason, like you mentioned, they need a way to apply control and policy there without having to go back to the developers, without having to try to call the provider, say, hey, can you change your service? They need a place to apply and govern that communication, and that's where the AI gateway would sit.
Yeah, I think that it's obviously from our background, but I think what we're seeing with real customers and users in the community, just how like way more than just applications, right? In cloud native environments, how important the network is as a control point and enforcement point in these architectures.
Yeah.
Cool.
So it's kind of, go ahead.
No, I was going to say, I think, there's so much buzz about agents, and I think rightly so, but at the end of the day, they're just networked applications. And so and we know a thing or two about networked applications.
Yep.
Well, awesome. That was funny, Keith.
Just kidding. I'm just, it's funny. Christian and I'm wearing a Solo shirt, like from KubeCon. He's got a Solo shirt on. You're the cool guy with like a concert t-shirt on. And
okay, I had my Carhartt Solo IO sweater on, but then I was sweating, and I'm sorry I wasn't wearing multiple layers of Solo in preparation for my live stream.
We're just gonna need you to raise
your wardrobe in depth, Eitan. Yeah. Come on
now. One Solo layer comes off and another Solo layer underneath. Yeah.
Just wait till I show my Solo underwear. No, don't worry.
Well, that's great. I mean, like that's I love it. It is just like maybe as we're wrapping up here, man, it's fun to demo this stuff. Like it is like it's really interesting to see how the pieces connect together. It sort of reminds me of why I fell in love with just computer science in general and development and like this idea, the layers to the onion, right? And you understand the outside layer and then you peel it, like there's a whole other layer underneath that, right? And I think one of the things that's very cool about just when we're doing demos of kagent and talking about all the connection points and what you have to interact with and the various components of an agentic architecture, I think it's fun to tease that apart and not just think of it as an atomic unit, but understand the underlying layers. And then also just how much, like when we see demos that you do for users, Christian, about just normal platform engineering and DevOps workflows, and people are just like, what just happened? Like that's one of the best feelings in a demo, right?
Yeah. I mean, that's all, the beauty of it is people are actually doing this. They're starting off, they're not throwing fully autonomous read-write capable agents into production right now, but they are going down this path. They're learning all of these pieces, learning all of the layers of the onion, and then they look around. They're like, "Oh yeah, I've seen some of this before."
Yeah.
Cool. A cool stat. Someone just told us in the community meeting, which you should all go to, that their mean time to deduction of issues with kagent is at 6 minutes from 30.
Wow.
Yeah.
That's huge.
So, that's a lot.
AI reliability engineering.
So Chris just asked the question if the recording is going to be available. I don't know, but I think, Christian, you have a blog. You just blogged about this, right? I think you have a.
Oh yeah. The recording should be available. But here, let me see.
Surprised to you, like
I do.
So many blogs.
That's so true.
There's been a lot. There's been a lot going on.
I'm such a prolific author. I can't keep track of all the
So, Chris, the answer, I don't know 100% about the recording, but absolutely, we'll post the blog. Would that be on Solo's blog or?
Here, I got you. It'd be a K Gateway. Wait, what's the blog we're talking about?
Didn't you say you were doing a blog about Kgateway and
on kagent? Yeah, I did.
Yeah.
That is on the kagent blog.
Oh, okay.
There you go.
There it is. So, Chris, the first entry in the on the kagent blog tab. So
yeah.
Hey, what tool are you using for those cool the GIF diagrams, by the way?
This one is Sketch Wow.
Is that the one where you have the animation and like some of the other ones you do?
Yeah.
Where okay, gotcha. Yeah.
Not Sketch. Whoa.
Not Sketch Wow. Wow. Look at that.
Wow.
That's wow.
Actually, it's vaguely Excalibur-ish.
It is. It is like
vaguely.
Yeah. They. Cool. All right. Any other questions before we wrap from folks in the? While we and just Eitan just mentioned it, but weekly now we have both this live stream where we sound off on things that we just see in the community or that come up. We'd love participation. Anybody that wants to come on and join us in the crazy back and forth on the live stream, you're more than welcome to do so. But then also Lynn runs the community meeting every week. That's a more of a format where we jump on Zoom and it's a lot more interactive. You don't have to talk if you don't want to. You can just tune in and see what people are up to. That's talking about what people are doing with the kagent in the community, tackling sort of like, you know, community business in terms of what to work on this type of thing. So definitely check that out if you have a minute. All right.
Awesome.
You know how to wrap this up, Christian? Or are we just going to stare at each other for the next half hour until this?
That's it. Goodbye. No. Yeah, no. Thank you all for joining. Check out the previous streams, and hopefully we got Peter back next week.
The audience certainly hopes so. You did a good job, Christian. I give you a B+. You get a B+.
Yeah.
Oh, I'll take that. Right. I'll take that.
On a curve, so it was actually like a 70. No, I'm just kidding. All right.
Yeah.
See y'all later.
See ya. End stream.